Section 7.2, absolute value functions. Okay, I just want to tell you that question 7a has a typo in it. It's missing a negative sign. So just when you come to that, the answer book has the correct answer, but the question itself tried to trick you without a negative. Okay, an absolute value function is a function that involves the absolute value of a variable. So we're dealing with functions. We're going to have y equals, and we're going to have graphs. The graph shows some functions and their related absolute. Okay, so here's a graph of a function, a linear function, right there. And here is its absolute value. So you can see it started with the graph, but as soon as the y values became negative, it then mirrored or reflected about the x-axis. It said, nope, the absolute value of -1 is 1. The absolute value of -2, well, that's +2. So it's like it just mirrored. It started going towards the x-axis. As soon as it hit the x-axis, it said, nope, positive. And it almost was like a mirror. Okay? Here's a graph of a quadratic. So we have a nice, beautiful quadratic. There's a vertex. It has some x-intercepts. It has a y-intercept. So this part of the graph was totally okay. Nothing wrong with that. But as soon as these negative parts came in, that's where the trouble came, and they just became reflected. Okay? So it said, nope, these negatives can't be allowed. I'm going to reflect about the axes. Okay? So to graph an absolute value function, you need to make a table of values, then graph it, or you could use f of x and negative f of x, and for whenever we use the negative of the function, all negative y values are reflected on the x-axis. To analyze an absolute value function, we need to graph it, identify the characteristics, such as x-intercept, where y equals 0, y-intercept, where x equals 0. And then we could look at minimum values, domain, all the x values, range, all the y values. You can write any absolute value function as a piecewise function. This is going to be important. Piecewise means there's pieces of different functions. Each piece has its own specific domain. So we write it as y equals f of x whenever f of x is greater than 0, negative f of x if f of x is less than 0. The domain of an absolute function is the same as the domain of y is equal to f of x, so all x values. The range depends on the range. For an absolute linear or quadratic, the range will usually be all y is greater than or equal to 0. An invariant point is a point that remains unchanged when a transformation is applied to it. Okay, let's give this a shot. We're going to graph this absolute value function. Consider the absolute value function y equals 3, absolute value of 3x minus 1. So let's determine the x and y. For the y-intercept, we have to let x equal 0. So we're going to go y equals the absolute value of 3, let x equal 0, and we're going to evaluate this. So this is 0 minus 1. The absolute value of minus 1 is 1. So we have a point at 0 and 1. Okay, let's do the x-intercept. We're going to let y equal 0. So 0 equals the absolute value of 3x minus 1. Remember we said last section that the absolute value of 0 is just 0. So this has to be 0 in order for that to be 0. So we're just going to set 3x minus 1 equal to 0. We get 3x is equal to 1. X is equal to 1/3. So our other point is 1/3 and 0. Okay. Now what it says is we're going to graph this, so we need to make a table of values. Well, when we put x in, when we put 1/3 in, 3 times 1/3 is 1, 1 minus 1, we get 0. Let's put 2 in. 3 times 2 is 6, minus 1 is 5. The absolute value of 5 is 5. Okay, we're going to skip this 8 for a second. Let's look at -1. 3 times -1 is -3. -3 minus 1 is going to be -4, and the absolute value of -4 is positive 4. -2, 3 times -2 is -6, minus 1 is -7, absolute value of -7 is positive 7. And finally, negative 3. 3 times negative 3 is negative 9. Negative 9 minus 1 is... Oh, I made a mistake on my sheet. Okay, 3 times negative 3 is negative 9 minus 1 is negative 10. So we're going to get the absolute value of negative 10 is 10. Let's look at this. They want to know what 8 is. So basically what they're saying is 8 is equal to the absolute value of 3x minus 1. So what x's make that true? So first of all, we could look at, well, if this whole part was positive, then we would have 3x minus 1 is equal to 8. 3x is equal to 9, x is equal to 3. So one answer here is 3. Okay, but there's another answer. If this whole part was negative 8, then we would also get the same answer, right? Because the absolute value of negative 8. So what I'm saying is if this whole thing in the middle was negative, it would also give us the answer. How did I write that here? Okay, so this would be negative 3x plus 1 is equal to 8. This would give us 3x is equal to 7. Negative 3x, x is equal to 7/3. Okay, so there was actually two answers here. Interesting, two answers. Oops, 7/3. Okay, now let's plot these points. So we have 1/3 and 0. X is equal to 1/3 and 0. Okay, then we have 2 and 5. We have 3 and 8. We also have negative 7/3. So that's just over 2 and a little bit, and 8. We have negative 1 and 4. We have negative 2 and 7. And we have negative 3 and 10. Okay, so you can see that this graph is going to look something like this. Okay, so what's interesting about this is the original graph seemed to go like, would have kept going like this, but as soon as these were negative values, they started to become, this started to be mirrored or reflected, and I did a poor drawing there. They started to become reflected. You could see each of these points, these negative points, was then reflected to be positive about the x-axis. Okay, so there's our sketch. Next question, it says, state the domain and range. Okay, so of this green graph, let's think about domain, all the x values. Well, I could put any x value in, and this graph would continue going. So my domain would be x, such that x is a member of the reals. So basically, I'm saying I could put any x value in. Okay, now let's look at the range. The range is more confusing. So for y values, I can't have any y values under here. It only included positive y values. So I say my range is all y such that y is greater than or equal to 0. Oops, sorry, I write it like this. Y is greater than or equal to 0, and y is a member of, I can't write today, y is a member of the real numbers. Okay. Last thing it asks is to write this as a piecewise function. So remember back from the first page, piecewise means that we write y is equal to f of x is f of x is greater than or equal to 0, and y is equal to negative f of x if it's less than or equal to 0. Okay, so let's set that up here. So we're going to write y is equal to 3x minus 1, any time from here on. Well, this point was 1/3. Whenever x is greater than or equal to 1/3. It's, this function is equal to negative 3x minus 1 whenever x is less than 1/3. Right? As soon as we started going less than 1/3, it was reflected or negative. Okay, oops, and then I do that. So there's your first example. I will do another example if you would like, and that will be on another video.